Hello guys, good morning. Welcome to the session today. Hope you all can hear me. Can you guys confirm once? Am I audible?
Yes.
Okay, great. So guys, in yesterday's session we have seen what is BigQuery. Let us just recap it. So BigQuery is one of the modern data warehouse and it is a serverless platform and it is highly scalable. And when I say a serverless platform, no need to create any server, any instance, any environment. If I wanted to work with large amounts of the data, we can able to directly go to the BigQuery, and here we can only work with the tabular data or structured data. We can define the schema properly. It comes up with a built-in query engine, which is capable of doing the SQL queries only, and are going to get a very good performance. Even terabytes of the data you can able to manage in a matter of seconds, and petabytes of the data in a minutes only. And you are going to get a very good performance without creating any infrastructure. So we don't need to create any infrastructure here, guys, and no need to create any indexes also. We are getting this kind of a the performance. It's because of BigQuery follows a columnar storage model, and here both reads as well as updates are very faster for the BigQuery. And when you go for the traditional systems, they are mainly designed for the insertions rather than the analysis. And BigQuery provides both batch as well as real-time data analytics. But if you go for traditional warehouses, they only support the batch data analytics. It does not support the real time. And the hierarchy. One minute, guys. So if you wanted to work with the data, if you wanted to work with BigQuery, the hierarchy of the BigQuery will be like this. So you will be having a project. Under the project, you will be having the data set. You will be having multiple data sets. For each data set, you will be having the tables, views, functions, and stored procedures and machine learning models as well. And if I wanted to work with BigQuery, what we can do in the BigQuery, if you ask me, here we can collect the data, whether it is a batch data or a streaming data, we can collect it. We can store the data in the BigQuery. We can process or transform the data in the BigQuery. We can analyze the data in the BigQuery. So all of these things we can do it in the BigQuery itself. Okay. And this is our BigQuery's architecture. There are three main components. One is Colossus distributed file system, Jupyter network, and REML engine. Okay. And working with the BigQuery, as I told you, for our project ID, we will be having the data set. Multiple data sets are there. For each data set, you will be having these many components. And whenever you wanted to use the table ID, we have to use the table ID instead of table name. The table ID is nothing but a project ID dot dataset name dot table name. Okay, so this is how it is. So let me go to the BigQuery now. So this is how the interface for the BigQuery looks like. So this is our editor, and here you will be having the project ID. Under the project ID, we have created the data set, right? So under the data set, you will be having the tables like this, customers table and students table. And yesterday we have created two tables. One is a customers table, which is a native table. For the native tables, you will be able to see that the native tables will be having both table structure as well as the data is managed by the Google itself, Google Cloud itself, or BigQuery itself, you can think of. So this is a native table, and let me open this one also. Sorry. So this is native table. The left one is native table. The right one is external table. The native tables, you will be able to see the data. the number of rows, and you will be able to preview the data also. Okay, you will be able to preview the data also. That is how the native tables looks like. For the external table, the external table means the table structure is managed by the BigQuery, but the data is external to the BigQuery. Whether it could be in the GCS, maybe in the Azure Blob storages, maybe in the S3 buckets. So now look at here, schema. So if you go to the details, you can see here it is an external table. You will be having the external data configuration where your data is available here. That is there in the Google Cloud Storage. Okay, so this is how, and you will not be able to see the preview of the data also. Okay, but whenever you wanted to run a query, you can able to run the query here for the this one. Select star from the table. This is for the native table. You will be able to native the table. You can able to query it. Similarly, for the external table also you can able to query it easily. So this is an external table. So you can able to query it easily. Okay, so this is how you will be able to see the data. Okay, so this is how you have the data here. Okay, so you can query both the tables, guys, but the external tables are little slower than the native tables. Okay, so this is how we can create the table, whether it is an external table or an internal table. We can able to manage them and we can able to easily query them. Okay, so this is how it is, guys. Any questions? So yesterday I could not be able to answer your questions. If anyone have any questions, you can ask me now, guys.
So in which scenario we will go for native tables and external? See, when we have the data outside of the any other storages, we will go for external tables.
It's not like that. It could be like this. The native tables we will be going for. I think, did I tell you yesterday also? I did not tell you. I think I might have told you, but anyway. So the native tables we will be going for most of the times. Your project is long and you wanted to run the analysis, or you wanted to transform the data and you are wanted to run the data. That means you wanted to run a lot of analysis on the data every day. Okay, you wanted to run the analysis on top of the data every day, and having the data in the Google Cloud Storage or Azure Blob Storages is like you are going to run the queries, but the analysis will be very slower. It takes a lot of time for the queries to run. In such a scenario, if you wanted to perform analysis every day, daily basis, if you wanted to perform the analysis, in that case, going to the native table is a very good choice. But, sir, on the other hand, you have external tables. So you don't want it to run the analysis daily. You just want to do it 1 or 2 times, and instead of moving the so when you wanted to do it 1 or 2 times, moving the data entire data to the BigQuery is the wrong choice. Okay, you just wanted to run the analysis 1 or 2 times, 1 or 2 days. Okay, instead of moving the entire data to the BigQuery, you can create an external table and query it. Okay, so that is what is the main agenda. So if you are doing the daily queries, then go for the native tables. If you are doing it ad hoc basis, go for the external table. Okay, and similarly here when you are storing the data in the native, the cost is more because additional cost. This is an additional cost. But for the external table, cost will not be there in the BigQuery because you are not storing the data in the BigQuery, right? So additional cost will not be there. So this is how one more criteria also. Okay, these are the two criteria you can go for. So if you wanted to run the analysis daily basis, go for native. Ad hoc basis, go for external. Any other questions, anyone?
Sir, this we created MySQL instance, right? Like if you want to use in applications like a .NET applications in Java applications, right? we can have like a username and password, anything for this from we can able to see those data details, driver
No,
name.
no. You can, I mean, if you wanted to retrieve the data from the BigQuery, I mean, you don't have a username, password details, but you can have your project ID details. And if you wanted to connect it to the BigQuery, you need to have a proper service account and keys as well. Okay, so that is how it manages. The BigQuery manages via that service account for the authorization, and you can able to initialize the BigQuery client. There is a BigQuery client for everything. For example, you are using the Python or Java, you will be having the BigQuery client to initialize it. You can go to the BigQuery documentation. Okay, where is that? Okay, yeah, here it is. Maybe Python client or whatever it is. Okay, you we have to initialize the BigQuery client like this. For example, you wanted to run any query, so from the Python, so this is using Python, you wanted to run any query, so you are going to initialize the Python client and you wanted to run some query, and you are going to do that. So this is how you can able to do it from the Python. Similarly for the Java, you need to just initialize it, but the thing is that in this scenario they have not mentioned the authorization. You have to do the authentication or authorization via service account and keys. So that is how it is. Okay.
So one more question, Rahul.
Yes, please.
So currently in my one of my project, we have a Snowflake database where
Okay.
our team is planning to migrate that. I mean, moving that Snowflake tables into the Google GCP, Google Cloud Platform. Okay.
Okay.
Uh, so Snowflake is not. I mean, Snowflake is not. I mean, in GCP we don't have that Snowflake database, right? I mean, currently it is supporting for MySQL, Oracle, and Postgres. Something. So only three databases it is supporting as of today. You said right in your initial
Correct.
classes.
Correct.
So
Correct.
how will they do it now? I mean, I'm not sure. I mean, if they want to move it, they will move the Snowflake tables data into the BigQuery directly. How it will be done? I mean, if
So
they
they
want.
don't do it directly. Okay, they don't do it
Okay.
directly. For
Okay.
every migration project also, if you do it
Okay.
directly also, what
Mm-hmm.
happens is that you are going to lose the control. The
Okay.
control in the sense is that,
Mm-hmm.
so you are directly migrating the Snowflake to the BigQuery. How much amount of a data you are migrating, you will not be having the control. Okay,
Okay.
and
Mm-hmm.
is the accuracy of the data is maintained properly or not, also not maintained. But even the BigQuery also does not directly support the Snowflake data source.
Yes. Yes.
Okay,
Okay.
so what you
Mm-hmm.
have to do is that what the people will do is that they will try to create a one more service in between. I mean, they try to use a one more service in between.
Mm-hmm.
They may use different services.
Okay.
1 minute. Sorry. So you can't directly move from the Snowflake to the BigQuery. That is one thing is clear, right? So what the people try to do is that, so we already know we can use one thing that migrate this entire data to the Google Cloud Storage. Okay, from the Google Cloud Storage, a BigQuery we can directly run it. So this is about the data. Okay, so there are two types. So whenever you wanted to migrate the data, so we have to understand this concept very clearly, guys. Okay, so whenever you wanted to migrate any data migration involves two things. One is table structure, nothing but a schema. Okay, and one more is data. Okay, first, are we going to create the entire tables in the BigQuery? First thing. So most of the time, what people try to do is that they try to create these table structures. They don't first move the data. They try to create this entire table structure in the BigQuery. Because what happens when you try to migrate it, right? So if you have the table structure properly defined, is there any changes in the data also, you will be able to easily find it out. So that is the reason the Snowflake table structure is different as well as BigQuery table structure is different. So you have to convert first from the Snowflake to the BigQuery all the table structure, because the data types or the schema may be little different in the BigQuery and Snowflake. So that is one conversion that we have to do first thing. Okay. And the next conversion is that from the Snowflake to the cloud storage, data will be moved. They may use different ETL tools, okay, and they will move the entire data from the Snowflake to the GCS. They will dump it from the GCS to the BigQuery. They can easily move it. Okay, so this is one way of doing it. So this is one method people use. And second method, sir, I wanted to my tables and all of these things are very simple, and I wanted to manage it differently. In that case, you can also use, instead of GCS, you can also use data flow. Data flow also you can use. So data flow also supports the data migration. Most of the times data migrations can also be done with the data flow from the Snowflake to the data flow to the BigQuery. Automatically, it will take each and every table. First, it will take one table and it will be creating the table here and moving the data for this same table, moving the data from here to here. So this is how, this is a one more method. But most of the times I'm telling you, this is the common method, guys. So because the process is streamlined with the GCS whenever you go for. Okay, GCS can handle any amount of data first thing. And one more thing is that whenever you dump any data in the GCS, managing the GCS data to any other service or integrating with any other service is easy. So this is method they may follow in your project, I would say, Naresh.
Okay, in this case, we will create the native tables or external tables in this scenario.
So most of the times it is native tables only. So your project, you tell me your data is in the Snowflake. Most of the times you have the data in the Snowflake native tables or external tables. So the same criteria. In the Snowflake also you will be having native tables and external tables. If it is native here, it will be native here. If it is external here, it will be external here. Yeah. Okay. So this is how. The same process, even though you mentioned the Teradata or you mentioned the anything, most of the times I would say I wouldn't suggest this method. Very rarely the people use it, but even people also using nowadays data flow also for MongoDB, all of those things. They have started using the data flow, but this is a choice. But this is not the method. But most of the times they will be going with this first method only. Yeah. Any other questions, guys?
Then what is Dataproc?
Dataproc is for Dataproc is also you can use in this scenario, but the thing is that Dataproc is mainly for the data workloads. Dataproc is mainly for the data workloads. Dataproc is a Spark environment. Okay, Spark environment. Sir, I have a intensive data processing pipelines I wanted to run. In that case, go for the Spark pipelines. Create a Spark pipelines. So those pipelines, whether it is moving the data or whether it is mainly the data proc is used for the data processing, guys. Data processing, heavy data processing I want. Heavy data transformations I want, and reading the data from the some source, and I wanted to have multiple transformations or processing, then loading it to the data. In that case, go for the data proc. And if you need the Spark touch, data proc. If you don't need the Spark touch, you need the beam touch, then you go for the beam, because the frameworks are different. That's it. Data proc uses the Spark framework. Dataflow uses the Beam framework. Dataflow is not that much faster to the Dataproc, because Dataproc is nothing but a Spark. Spark is the highest nowadays. We do not have any tool which is running more faster than the Spark nowadays. Okay, Spark is the highest one when it comes to the data processing. Okay, yeah.
These services are available, sir. Dataflow and Dataproc in GCS.
The Google Cloud Storage. We are going to start next thing Dataproc only. Okay, after that we are going to start Dataflow. Yeah. So that is how, guys. So whenever you wanted to do the data migration, I just wanted to tell you the steps so that whenever you are following, maybe in your company or in your project, if you are following some kind of a data migration project, not only for the GCS, for any data migration project, the very, very important first step that we do is that plan. So we need to properly plan it. The plan is that whether the Snowflake environment is having proper tables and we are able to access to it, and we have the proper migration plan or not. So this is what we call the migration plan. So because we have recently migrated the data from the Snowflake to the Databricks, and when we were doing it, I was the solution architect for that. So I had created an entire plan. Now it is running very smoothly. That we are about to complete it by this the 28th. 19th is the last date for the data migration. We are having a team of 15 members, and we have done it within 1 hour. I think more than 1 month. That's it. Not more than 2 months. Also more than 1 month, we are able to complete the entire migration process with 15 members team. So first we do the migration plan. In the migration plan, we specify what is the amount of data. So in the migration plan, we need to come up with a strategy that we are dealing with the volume of our data. What is the volume of the data, and do we have any dependencies? If we have any dependencies, we need to follow. And are we able to access the Snowflake environment? Not only Snowflake, are we able to access the source environment properly? And are we setting up the access control for the source? Access control, let us say access means access controlling the access control to the source environment. And how many objects are there? So we are going to mention, do we have tables? Do we have stored procedures? Do we have views? So we need to mention all of these objects and how we are going to migrate each and everything. We need to come up with a plan. And do we have any functions? Okay, so all of these things we need to identify, and we need to create a chart where it provides all of these things. So you can call it as a migration plan. Once the migration plan is properly done, we need to do two things. One is, as I told you now, schema migration, and then data migration. Okay, schema migration. In the schema migration is that we need to create that schema in the BigQuery according to the source schema. So for example, we have the source, right? We have the source environment. According to the source environment, we need to find the equivalent schema for the destination environment. We need to find the equivalent schema. For example, sir, if you go to the BigQuery and MySQL, so we have done many migration projects. Yes, for example, in the MySQL, you call it as a varchar. I think in the Snowflake also. So, but in the BigQuery, you call it as a string. So you need to find the equivalent schema for the source environment as well as destination environment. Then only you will be able to create the properly all the tables. Then once you have found this equivalent schema, then you start creating these tables, empty tables. You are start creating these empty tables. Okay, tables or views or whatever it is, you start creating it. Okay, so this is how it is. Okay, once you have started creating it, you call it as a data migration. The data migration is that from the source environment, you may be having your own method of moving the data. You may be using some ETL tools to the Google Cloud Storage and Google Cloud Storage to the BigQuery. So you
So
can
we
use
that ETLs to run it multiple times for a given day. See, I have a Snowflake database, right? That is a production database. Okay.
correct.
So for every half an hour or 1 hour, I want to get that whatever changes are done in the production environment, that data needs to be copied over to the GCS. So once we
Correct.
have the data in the real-time data in the GCS, then later some other applications can access to this BigQuery and show that data into the downline
Correct.
applications.
Correct.
Okay.
So this whatever you are saying, the timings can be managed here only in the ETL.
Okay. Okay.
Okay, so the timings and all of those things. And here also you need to think about one more thing during this data migration, which format we are going to use. It also very important, because sir, I go for the CSV, Avro, Parquet. So you need to define which format you are going to. Sir, if you are going to the text files, which is a heavy file and which is not very faster, so we suggest you to go with an Avro or Parquet. Most of the times people will go with a Parquet format. So this is also you need to define which format you are going to do it. Okay, and after that you can manage, you can easily import the data to the BigQuery. Whether you can use any other tools, many tools you can use it, or you can also directly do it. That is also possible. Okay, so ETL, sorry, source environment to the ETL to the GCS, and you need to finalize the format also, and you can also use to the BigQuery. Okay, so this is how it is. So for migrating it from this Google Cloud Storage to the BigQuery, you can use any other tools also. Okay, you can use BigQuery internal tools for processing tools you can use, or you can use third-party tools also. It's your choice. It's your choice. So most of the times people will be using the Google's internal tools only, data transfer tools. You can also use data transfer tools. In the BigQuery, suppose the data transfer tools also. Okay, so this is how the data migration. And fourth thing is, which is called as a workload migration. People call it as a workload migration, or some people call it as a code migration. Okay, workload or code migration, you can call it as anything. What is this one is that by using these source tables in the BigQuery, you guys are creating some external tables. So there are two types of set of tables. You have a raw tables, you have a curated tables, or you have a bronze tables. You may be having silver or gold tables, which are silver and gold tables are created from the bronze tables only. So if you wanted to create those tables, those SQL queries also to be migrated. So you have some SQL query in the source, so that has to be properly migrated or converted to the BigQuery code. Okay, BigQuery equivalent code. So this is also one of the important steps. This is one of the important steps because these two things can be done easily, but finding the equivalent code for each and every SQL query is not that easy. It takes time, but it can be possible. So this is what we call as a code migration, or you can call it as a workload migration. Some people call it as a workload migration also. Okay, so this is one more thing, sir. We need to convert all the Snowflake SQL queries, stored procedures if you have, or the tables if you have. Everything need to be properly migrated to the BigQuery code. So BigQuery SQL code, because the SQLs are different. This is a Snowflake flavor of query, and it is a BigQuery flavor. So those two things are different. So we need to do that. And whatever the aggregations that you are using, joins, as well as ranking functions, window functions, whatever the data transformations that you are using, you need to find the equivalent code. So that is the important. This is actually the major step most of the time. This takes a lot of time. Major step. This is the major step. Okay, once you have done it, that's it. You may be doing some kind of a testing. Final testing will be there. So you will be doing some kind of a testing to ensure that accuracy. To ensure the accuracy and completeness, people will follow different methods. So this is also sometimes people will ask you in the question, sir, how do you ensure the accuracy in the project? So most of the time people are following with the hash algorithm. Maybe in our project where I have worked as a solution architect, I have suggested the hash algorithm two times hash algorithm we have suggested. So this hash is, I forgot that hash name. 1 minute, guys. There are different hashes available. Python hash functions. I forgot that name. Let me just not hash function, hash algorithm. Yeah, SH256. Yeah, here it is. SH250. Very famous, guys. So most of the times people will be going with the. I go with the SH256. It's because SH256 is common everywhere. Okay, so what I'll try to do, what is this one is that very interesting thing. Try to look at here, guys. So what we try to do in the testing is that we wanted to ensure the data is accurate. So what you try to do, you go to the source, and for each and every record, okay, let me create a diagram and try to tell you so that you will be able to understand this point. So assume that you have a table in the source, and the same table you are migrating, and you have the data in the BigQuery also. Yes or no, guys? You will be having both of these things, the same table, and you will be having here. This is one table. This is one table. Okay, so these are the two tables. This is the source and this is your destination. Okay. What people try to do to ensure the accuracy is that two things they will follow. To wherever you wanted to ensure the accuracy, two things you can follow. One is count, the count of the table. So the count is 100 here. The count is 100 here. So to whenever you wanted to check the accuracy, okay, sorry, not accuracy, completeness. There are two things in the testing, guys. Completeness is nothing but whether the data is complete or not. So here we have the 100 records, here we have the 100 records. That means your data is here as well as here it is same. That's where you can say that data is complete properly. So completely migrated from the source to the destination. That is one thing. And the next thing is accuracy. Whatever the data, for example, here we have the 100 records, here we have the 100 records. We can say that the data is complete, but we cannot say it is accurate. So you need to know for you need to find the accuracy also. The accuracy says is that this is one line. Okay, the accuracy says is that here we have 100 records. These 100 records with all the columns, 100 records with all the columns. See same the 100 records with all the columns or not. We need to find it out. That means record by record. For example, here we have 1 R 1,000 100 or some age 29. If we have this is same as this one or not. Okay, if it is same, you will be able to say same. But we are dealing with a very huge amount of data. We cannot go each and every table and look at each and every record with the naked eye. It is not possible. Manually doing is not possible. What people try to do is that they will try to create a SHA 256 key, SHA key, hash algorithm key. They will try to create. Using the SHA 256 hash algorithm, all the databases supports SHA 256. So that's the reason I suggested SHA 256. You create a one key for all of these records. For example, I'm going to create SHA key. Similarly, here also using the SHA 256, you create a one more key. So key 1 is equals to key 2 or not. If it is key 1 is equal to key 2, then you say that accuracy is there. And if Q1 is not equal to Q2, then the accuracy is not. And you will also get to know that how many records are accurate, how many records are not accurate. And you will also find out what is the reason it is not accurate. So based on that, you may have to change the code migration. Because sometimes when you are migrating it, you might have done some silly mistakes or you might have not properly migrated it. Now you will get to know here that when the data is not accurate, you will get to know here. Okay, so that is how this is what people do. There are two things. Some people will, whenever they are migrating it, they might have taken a wrong column. Okay, or they might have the data when they are migrating it from the Snowflake to the BigQuery, it may have some kind of additional what we call as a some extra elements might be created, dot or slash or something like that. Okay, so such kind of a things we will get to know in the accuracy only. So these two steps are very, very important to test your data to ensure the accuracy and completeness of your data. So this is what is data migration, sir. So whenever you wanted to go for the data migration, these steps are mandatory. Okay, any question, anyone? So this is actually very interesting. Most of the people does not know about it to ensure the accuracy. So two things you need to follow. One is completeness to ensure that the data count here as well as here is same. This is about the count and this is about the actual data. Is the data is actually matching or not? Record to record. So that is accuracy.
So
Yes.
is that comparison is applicable at the row level only? Let's say if I have millions of rows.
This is row level only. This is row
So
level
how much?
only. This comparison is low level only.
Okay, if I have millions of rows, how much time it will take for
It
comparing?
doesn't take much time. SHA 256 is very, very faster. It doesn't take much time. And one more thing, these SHA 256 and all of these things are inbuilt functions in every
Okay.
database.
Yes.
So
yes.
when you are using the inbuilt, it is even still faster. Okay.
Okay.
Yeah.
Right.
Okay. So this is how the migration strategy, guys. Okay. So that is how back to the Google Cloud Storage. Any other questions, anyone? So this is how In the BigQuery, even we wanted to create any table, we can able to create in a many different ways. And I have told you, for example, sir, I wanted to create one of the way. I wanted to create a table from the Cloud Shell. I have told you how to create a table from the editor, and I have also told you how to create a table from this. Where is that? So I have also told you how to create a table. Okay. So I have created it. We have created a table, customers table from the editor. That is nothing but by writing the code. And we have created a table from the console. That is like clicking on create table command. This is console. And I will also tell you how to create a table from the Cloud Shell. So that is important step. That is also I will show you. Then we can able to close the session for today. Okay. So let us see here, guys. So if you wanted to assume that you have a data in the Cloud Shell, or maybe in the cloud SDK, maybe in the local machine, and you wanted to run some command and create a table and load the data. Okay, that is also possible. So let me see if we have any tables. Yeah, here it is. I have here marks.csv. Okay, I have here marks.csv. So let me show you how the data looks like. So if I wanted to see the data, display the content of the data, we can use cat marks.csv. So this is how you have the student ID, subject, and grade. So we have it is a comma separated file. I wanted to create this as a table in the BigQuery and load this data. For that, we can use BQ commands. So whenever you wanted to interact from the Cloud Shell to the BigQuery, you can use BQ commands. BQ commands are nothing but to interact with the Google BigQuery via Cloud Shell. So you can use BQ command line interface, which is already pre-installed. We don't need to install it. So BQLS, if you specify, you will be able to see the number of data sets inside the BigQuery. Okay, you can see here, guys. I don't know, but it is showing the answer. You see here, we have only one data set, that is bronze data set. If you wanted to see the tables inside the bronze data set, also you can able to see BQLS bronze data set. I know some error it is throwing. So request dependency normal doesn't match any supported version. Warning. Normalizer doesn't match supported version. Okay, but anyway, we have the answer. So here it is the customers table. Here it is the students table. You will be able to see here, right, sir? Customers table is a native table. Students table is a external table. You will be able to see easily. Okay, so this is how you can able to interact with the BigQuery. And now, sir, I have this data, marks.csv. I wanted to load this data to the BigQuery and create a table in the bronze data set. So let us try to do that. If you wanted to create a table in the BigQuery, very simple. So we can use bqload command. See clear. I'm going to write the command, guys. So bqload command, I'm going to do it. So 1 minute. Let me see the cat
So Cloud Shell, nothing but a command prompt, sir.
line interface. Yes, Cloud Shell is nothing but a command line interface. Yes. So we have, I've told you in our upcoming, I mean, in our previous sessions also, I have given you a very good understanding of Cloud Shell and Cloud SDK, if you guys remember. Right?
Okay, sir.
Yeah.
Okay, sir.
So now I have here the data. I wanted to create this as a table in the BigQuery. So the command is that I'm going to use bqload command. Bqload command is to load the data to the BigQuery. Okay. So if the table is not available, it also creates the table. So bqload. So what is your source format? You have to mention if it is a CSV file or a JSON file, you have to mention. So sir, it is a CSV file. I am going to mention it. Okay. And similarly, sir, I have a schema. We have to mention schema. Schema is equal. So the schema is, sir, I have here the student ID. Student ID is an integer, sir, int 64. Sir, I have here the subject. Sir, subject is most of the times it is string, comma. And here we have the grade, sir. And the grade is, I am going with the integer. You can see int 64 I am going with. Int 64. So this is how you have specified the schema also. Okay, so and here we have the header also, guys. So whenever you are creating the table from the console also, you are skipping the header, right? Here also we need to skip the header. Skip header, or actually leading rows. Sorry, I forgot. Skip leading rows is equal to 1. And where is your data set? My data is this one. This file name is this one. You can say MA. Okay, sorry guys. Sorry. Okay, that's the reason. I'll try to write the code here on the notepad and try to paste it there. Okay. The command is bq load. Okay, bq load command. And we can use line continuation also. That is totally fine. Source format is equal to CSV. Schema. I think we have the schema here created. So I'm going to use this schema. And keeping leading rows is also there. Okay. So this is how skipping leading rows is also there. And after that, where is your data? Sir, my data is already there in the same path. So I'm going to say marks.csv, that is my data. Okay. And where do you want it to move it to? Where do we want it to move it to, guys? Sir, I wanted to move it to bronze dataset. Bronze dataset. Dot.
Does it create a table also for this CSV data?
Yes, it will also create a table. If the table is not there, it will create the table. And the table I wanted it to be marks table. See here, I'm also mentioning the table. So it will go to this. So this is how bq load command. The source format is CSV. So whenever you wanted to create the table, we need to specify the schema must, and you are mentioning it. Skipping the leading rows. You must specify the leading rows, guys, whether you have the header or not. If you have the header, skip it. And where this data will go to this table. If the table is available, it will directly append to the data. If the table is not available, it will create it, marks table. And the data will be coming from this marks.csv. Copy this entire command. You can go to your Cloud Shell. Okay, so I'm going to paste here. Okay, so this is how our code looks like, guys. And click on enter. Something wrong. Okay, seems like something wrong with the file, guys. 1 minute. Give me 1 minute. I'm not totally sure what is the wrong with the file. Okay, let me click on editor once and let me see if the file is in the proper format or not. Okay. Marks.csv, that's totally fine, but I'm not sure. So let us see the file. It takes days sometimes. Okay, no, yeah. Here we have it. I see it. It's perfect only. What's the problem here? Marks.csv in a perfect format. Okay, if this is not there, let me try to do one thing, guys.
Is there some warning message?
I don't know why it is showing that. So this marks.csv third-party request by request dependency error it does not match the supported version. Okay. I'm not totally sure about it. Let us try to take other data. I think let me look into it. So if I have any other data. Okay, other than this ones, why it is coming some some kind of a what we call these kind of issues will also come when you're actually doing the data migration. Also, what happens is that so there is this thing called I forgot that name also. Character string or whatever we call it as. I'm not sure. Guys.
Encoding
That
issue.
columns
Yes,
count is
encoding
matching.
issue. Yes, there is an encoding issue will also be there. So that is kind of a thing. But yeah, but I'm not sure. Okay, there is something wrong. So let us try to create this separate file and try to new file. Let me create it, and marks.csv is already there. Marks2.csv. I'm going to create it. So let us try to mention student ID. Okay, I have the data, guys, in some file. So let me gonna paste it here only. Control V, and it's the same thing. I don't know. Last time also I have done the same thing. I don't see any issues. Let me try to run it one more time. No, 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 no. Too many positional arguments still have some encoding issues. I see it, but it should work out. That's what I'm thinking. Let us go and see it here. If the table is created, if the table is not created. Okay, let me take any other CSV file, guys. If this is not working out, maybe it could be a problem with some CSV file or so. So let me take any other file if I have it any. I do not see any files now. So let me go to my, okay, so notes, not notes. Let me go here and click on Composer. Yeah, I have here one of the file. Let me do it, guys. Let me gonna migrate it to here. Maybe let us see this one. We'll get to know. It's not uploaded. Yeah, it is uploaded. Here it is sample data.csv. Okay. So for this one, we need to have the schema. Okay. So first, let us try to create the schema also for this one. Maybe we will go here and try to paste here, and we will try to mention everything as a string for now. Let's not worry about the schema. Okay. Everything will go as a string. I'm just creating a random schema, guys, but you now you got the idea, right? So how to create the schema. So that is important. And I have given the schema properly. Hey, there was this thing is wrong. So I have not closed it earlier also. Okay. Okay, I have closed it. Yeah. So we have the bracket on here. We have closed the colon also. And employee ID string, first name string, last name string, everything is fine. And it is, I wanted it to be employees table, EMP table, and then name is employees.csv, I believe. So that is, let me clear the screen, guys, and click on ls. The file name is employee.csv. Okay, so you can say employee.csv and copy this entire code, go here to our cloud shell, paste here and run it. Okay, something is wrong today, maybe.
When I see that there is no schema parameters, or I think after CSV file, they put the schema in the single quotes. That's what I see in the documentation.
No, it's the same. No, no, no. It's not about that particular code. It is about some Cloud Shell issue.
I pinged you just now. Do you see that my chat? That's how it is. Looks like in the Google.
I mean, there's a schema for sure. We can add it. You are added it to the. I mean, I don't see anything. You have pasted anything in the chat.
I put it to you right. Okay, I put it right.
Oh yeah.
And it's
Source format. They have not mentioned the schema. It's because okay, it's fine. I mean, anything is fine, guys. Okay,
yeah.
So that is also fine. The thing is that see here, even though I'm mentioning it as cat marks.csv, also we are getting the same error. Okay, now it is showing. Now it is showing. And what is the problem with this command then? Too many positional arguments from where we are getting this data. So this is the wrong. Somewhere we are getting too many positional arguments. Let me change it to the single quote and let us try it out. I mean, I have not faced this error, guys, so far. Okay, this is the first time I'm getting this. So we are getting this one. Still have too many. This is a error, guys. I don't know. Some supported version it is asking, which I don't get it exactly.
So that CSV file, do we need to mention any path? How it will identify the CSV file is available in which location exactly?
We have mentioned that, right? So see, for example, if I say cat marks.csv, if I mention it, are we mentioning the path? Because that is already there in the current working directory. So when it is already there in the current working directory, we don't need to mention the path. Okay. So marks.csv is there in the current working directory. So that is how it will identify directly.
Okay, okay.
And okay, so what was our code? This is our code. Not sure. Okay, it's done. I don't know, guys. So sometimes we are getting this error and still it is getting done. I don't totally know it. Maybe for you it might work, guys. I want you guys to try it out. Okay. So some issue with my Cloud Shell today. What I will do, I'll try to restart it out later. Okay, I'll try to restart it out later. But you don't face this issue, guys, for sure, because this is some library missing. I was working with some other SDK details. I might have, updated it, or I might have low graded it. I might have done that. So that could be an issue from my end. But for you, it will be done. For me also, it is done now. That means if I go and refresh it here, the command is same. BQ load command is same. Whatever I have explained here, the command is for sure it is same thing, guys. There is no changes in the scheme. The command is you can run it out also. And you see here the table is also created, employee table successfully. So we have all the columns and we have all the details. 15 records also loaded. And you can able to see the data also. Okay, so this is how it is. So this is how from the Cloud Shell also we can able to load the data. Okay, from the Cloud Shell also we can able to load the data. Any questions, guys, now? Okay, so this is where this many ways we can able to create the table and load the data to the BigQuery. Okay, yeah. Any questions? I'm gonna copy and paste this command. Just change your table name, dataset name, as well as your file name, so that you can able to try it out, guys. Okay, if you wanted to try it out, yeah.
So one question I have, like what are
Yes.
the services we covered in this 499 rupees session, and what are the remaining things in this session? How many days it will take?
So we are going to cover an end-to-end project to one thing. So for that one, whatever the services required, I'm going to cover here. Okay. So
Okay.
for that one, almost all the services for the data engineering, which are important, I wanted to go for a job. So what are the important data engineering services are covered here already? Will be covered here. Okay.
Okay. Okay.
The basic concepts will say data engineering. So we have covered already the GCS and the Google Cloud SQL as well as BigQuery. So these are very important. And data proc and data flow also we are going to cover. And the next thing is cloud functions. And after that, we will see the end-to-end project.
Okay. So VM creation and all these things will not be under
It's
this.
not a data engineering. It's not a data engineering.
Okay.
Okay, but I will tell you what is VM, what is Kubernetes. I will tell you the understanding. I will tell you, and I will also tell you how to create it. Also, we will be creating it. Okay,
Okay.
but
Okay.
the thing is that that doesn't comes under data engineering.
Sure.
Okay, okay, guys. I think we are good. Anyone have any other questions? Okay, I think this is it, guys. So we will see a few more things. Maybe tomorrow we will start with the data proc and we will try to understand what is data proc and we will try to create the jobs also. Okay, yeah. Okay, guys, thank you all. We will see a few more things tomorrow.
Thank you.
Thank you.
Yeah, thank you.
Thank you.
Thank you, guys.